As of this morning, the Met Office is watching heatwave conditions build across southeast England again, with temperatures expected to climb back toward the low 30s by Thursday. If that sentence feels like something you have already heard this summer, that is because you have twice. Britain has now lived through its third heatwave of 2026, a stretch of 34 to 36 degree heat in early July that triggered amber health alerts, Brookie. Kicked the national record for the most 34-degree days recorded in a single year, and pushed emergency ambulance calls to a new single-day record. And now, less than 3 weeks later, the same basic setup is reassembling itself over the country. Meteorologists tracking this pattern are not describing it as a coincidence or simple bad luck. They are pointing directly at the jet stream, the high-altitude river of wind that is supposed to steer storms and cool air across Britain on a regular rotation, and they are increasingly confident about why it keeps failing to do that job this year. This is the story of what actually happened during Britain's third heatwave, why the jet stream keeps bulging north around Europe instead of flowing through it, and what an unusual patch of cold water sitting south of Greenland has to do with all of it. No exaggeration, just what the Met Office, the UK Health Security Agency, and the ocean and atmospheric scientists studying this exact mechanism are actually reporting. Drop a comment and tell me how many separate heat waves you have personally lived through in Britain this summer, because if you have genuinely lost count at this point, you are living through exactly the pattern this video is about to explain in full. I read every one of these. If you want grounded weather coverage instead of recycled panic, subscribe. It is free. An A-like helps this reach people before the next one of these builds over their own city. Let us go for 5,000 likes on this one. Now let us get into it. To understand why Britain keeps sliding back into heatwave conditions every few weeks rather than settling into an ordinary changeable summer, you first need to understand what the jet stream is actually supposed to do. It is a narrow, fast-moving band of westerly wind high in the atmosphere, formed where cold Arctic air collides with warmer air from further south. And under normal conditions, it acts like a steering wheel for the entire northern hemisphere's weather, pushing low-pressure systems and cooler air across Britain and the rest of Europe in a fairly regular rotation. When that temperature contrast between Arctic and mid-latitude air is sharp and consistent, the jet stream tends to run relatively straight and fast, which is exactly what keeps weather moving through rather than sitting in place. When that contrast weakens, though, the jet stream tends to slow down and grow wavier, bulging further, north in some places and further south in others, rather than holding a steady, predictable path. Those exaggerated northward bulges are precisely what allow a dome of high pressure to build and simply sit over a region for days or weeks at a time, trapping hot air underneath it like a lid rather than letting the normal churn of Atlantic weather systems break it up. Meteorologists sometimes describe the more extreme version of this pattern as an omega block, named for the shape it traces across an upper-level weather map, a ridge of high pressure flanked on either side by dips in the jet stream that together resemble the Greek letter omega. And because that configuration is locked in place by the troughs surrounding Giat, rather than being pushed along by the jet stream's normal flow, it can hold a single patch of ground under direct sun for far longer than an ordinary summer high-pressure system ever would. Britain's own third heat wave of the year followed exactly that pattern. Temperatures began building across southern England from start of the week of July 6th, climbing through the low 30s, before peaking at 35 to 36 degrees Celsius on the Thursday and Friday, with the UK Health Security Agency issuing amber heat health alerts, warning of significant impacts across health and social care services. Although this particular heat wave did not reach the exceptional peaks recorded during June's earlier heat spell, when Norfolk recorded a record-breaking 37.7 degrees, it still proved serious enough in its own right to spark record-breaking demand on emergency services, with the BBC reporting a new single-day record for ambulance calls tied directly to the heat, and separately confirming that the country had broken its all-time record for the most individual days reaching 34 degrees Celsius within a single year, a record that fell before the summer had even reached its traditional peak. Met Office Deputy Chief Forecaster Stephen Keats was direct in describing the pattern at the time, confirming that parts of the UK were entering their third heat wave of the year so far, a phrase that, on its own, tells you something has shifted structurally in how this summer is behaving compared to an ordinary British year. Here is where the story moves, from simply describing what happened to explaining why it keeps happening, and the leading scientific explanation traces back to an unusual, comparatively cold patch of ocean water sitting just south of Greenland and Iceland, a feature researchers have taken to calling the cold blob. While the rest of the planet's oceans have been warming, this specific patch of the North Atlantic has been doing the opposite. And Marilena Oltmans, a researcher at the University of Bremen, who led a 2024 study on exactly this feature, has explained the mechanism plainly, describing how the jet stream bends northward and flows around Europe instead of crossing directly through it once that cold patch collides with the warmer water surrounding it. That sharp temperature contrast between the cold blob and the ocean around it distorts the air directly above it, and Oltmann's research links the cold blob's presence to meltwater pouring off Greenland's ice sheet, fresh water that dilutes and cools the surface of the North Atlantic in a way that alters the broader pattern of ocean circulation. Once the jet stream bulges northward around that cold patch, it opens a corridor that allows warm, moist tropical air to push much further north than it normally would, precisely the air mass that then gets trapped beneath a stalled ridge of high pressure over Britain and the wider continent. That is not the only mechanism scientists are pointing to, and it is worth being clear that this is an area of active, ongoing research rather than a single settled explanation. A separate body of research has focused on Arctic amplification, the well-documented phenomenon where the Arctic is warming considerably faster than the rest of the planet, narrowing the overall temperature difference between polar and mid-latitude air that powers the jet stream in the first place. A recent study published in the journal Nature Communications, examining weather data stretching back to 1979, found that as snow cover across northern Canada has declined, the jet stream has grown measurably wavier, allowing warm air to settle over Greenland for extended stretches and accelerating ice melt there, a feedback loop that plausibly reinforces the cold blob mechanism rather than competing with it. Liz Stevens, a climate scientist at the University of Reading, who was not involved in that research, described the practical consequence of a stalled jet stream plainly, noting that when it settles into a stationary position, weather systems get stuck in a holding pattern that allows heat to build up across whichever regions happen to be sitting underneath it, whether that is southern Europe, southern North America, or eastern China. It is worth being precise here about what current research does and does not fully establish, because a genuinely new scientific mechanism deserves that same caution. Any legitimate finding does. Scientists have been documenting signs of the jet stream shifting northward and slowing down for more than a decade, including a 2021 study led by a University of Arizona researcher that projected this migration continuing through 2060 and warned that its early stages may have already begun. What remains actively debated among researchers is precisely how much weight to assign each contributing factor: the cold blob, Arctic amplification, and background global warming in any single summer's specific pattern of heat waves, since these mechanisms interact with each other in ways that are still being actively modeled rather than fully settled. No scientist studying this claims the cold blob alone guarantees a heat wave in any given week, only that its presence measurably tilts the odds toward the kind of stalled, wavy jet stream pattern that makes prolonged heat domes considerably more likely to form and persist once they do. There is a useful historical comparison here that helps put this year's pattern in context. The summer of 2022, still remembered in Britain for the country's first ever verified reading above 40 degrees Celsius, also unfolded across 3 distinct heat waves, rather than a single continuous hot spell. And climatologists studying that summer explicitly linked the extreme heat to changes in the jet stream driven by climate change, with researchers noting that Europe's heat wave frequency has been increasing at 3 to 4 times the rate seen across other northern mid-latitude regions, like the United States, precisely because of how directly the continent sits in the path of this exact jet stream mechanism. 2026's pattern, 3 heat waves by the end of July, with a fourth already building, suggests this is not an isolated repeat of one unusual summer, but a structural feature of how Britain's climate is currently behaving, consistent with what jet stream researchers have been warning was coming for years. It is also consistent with what has been happening well beyond Britain's own coastline this summer, since the same broad jet stream pattern responsible for this repeated UK heat has coincided with record-breaking wildfire seasons across Spain, France, and Italy further south, where successive heat waves, driven by the same stalled atmospheric setup, have dried out vegetation to the point that ordinary ignitions have repeatedly escalated into some of the largest fires those countries have recorded in years. A reminder that, wavy, slow-moving jet stream rarely produces consequences confined neatly within a single country's borders. So what does all of this actually mean for you if you live anywhere in Britain right now? The practical lesson is that this week's building heat should not be treated as an unrelated, standalone weather event, since it is forming through the exact same mechanism that produced the previous 2 heat waves. This summer, if you are in southeast England specifically, where the Met Office has flagged the clearest signal for renewed heatwave conditions by Thursday, plan strenuous outdoor activity around the cooler morning hours, keep an eye on any heat health alerts the UK Health Security Agency issues over the coming days, and check on elderly relatives or neighbors living alone, since heat-related health emergencies disproportionately affect older adults who may not recognize the danger in themselves until it becomes serious. More broadly, treat the summer's pattern as an ongoing condition rather than a series of unrelated hot weeks, Since the same jet stream configuration responsible for July's heat wave shows no clear sign of breaking down for good, and forecasters have been explicit that further spells of hot weather remain possible through the rest of the summer. Keeping a genuinely cool room available at home, staying hydrated throughout the day rather than only when you feel thirsty, and knowing which local cooling spaces or air-conditioned public buildings are available near you are all worth sorting out now, before the next heat health alert arrives, rather than scrambling once temperatures are already climbing. The honest, grounded summary is this. Britain has experienced 3 separate heat waves so far in 2026, with the most recent in early July pushing temperatures to 35 and 36 degrees Celsius, breaking the national record for the most 34-degree days in a single year, and triggering a record spike in emergency ambulance calls. Meteorologists trace the underlying cause directly to the jet stream, which has repeatedly bulged northward around Europe rather than flowing through it in its usual pattern, allowing domes of high pressure to stall in place for days at a time. Ocean scientists studying this specific mechanism point to an unusual patch of cold water south of Greenland, likely fed by meltwater pouring off the Greenland ice sheet, as a significant contributor to that northward bulge, working alongside a broader, well-documented pattern of Arctic amplification that has been distorting the jet stream for well over a decade. As of this week, the same basic setup is already reassembling itself over southeast England, suggesting this summer's pattern of repeated heat waves is far from finished. We are going to keep tracking this exact pattern the way we tracked it today, straight from the Met Office, the UK Health Security Agency, and the ocean and atmospheric researchers actually studying the jet stream's behavior, not recycled headlines. Subscribe so you do not miss whether this week's building heat becomes Britain's 4th heat wave of the year. Because based on everything we just walked through, this pattern has shown no real sign of breaking down for good. And leave that comment below. Tell me if this summer feels genuinely different to you compared to previous years, because that lived experience is exactly the pattern scientists studying the jet stream are trying to explain with hard data. Because behind every one of these heat health alerts is a nurse in an English hospital bracing for another record ambulance call day, a farmer in East Anglia watching the same dry soil bake for the 3rd separate stretch this summer, and a family finally opening their windows again this week, uncertain whether the cooler air will actually last this time, or whether the same stubborn pattern is simply about to reassemble itself over their home once more. 5,000 likes on this one. Let us go. See you in the next one.